Okay, so those are the answers for the worksheet on energy. So what is the kinetic energy? Right away you can write that kinetic energy is equal to 1/2 mv squared. You have a mass of 0.14 kilograms. You have a velocity of 18 meters per second. So your kinetic energy is equal to 1/2 times the mass, which is 0.14, times the 18 squared, which is your energy. And you put it in the calculator, obviously. So 0.5 times 0.14 times 18 squared, and you have a 22.7 joules. Now they say if the baseball above was initially at rest, which means potential energy, kinetic energy at the beginning was 0, so the initial, right, was 0 joules. How much work was done to give the energy of this? So the other kinetic energy, obviously, at this point was final, right, 22.7. So work, we said, is anything that makes you go from one energy to the other. So the work necessary to go from 0 to 22.7 is equal to 22.7 joules. Then a race car has a mass of 1500 kilograms. What is the kinetic energy in joules? If it has a speed of, so this is 110 kilometers, so that means times 10 to the third meters, divided by 1 hour, but 1 hour is made of 3600 seconds. So now this is your velocity in meters per second, and your kinetic energy is going to be 1/2 of the kilograms times the new velocity, which is 1110 times 10 to the third divided by 3600. This is 30.6, and you got to square it. So when you square this one times 1500 divided by 2, this is equal to 700,000. 231 joules. Then number 3, relative to the floor, what potential energy does a 2.5 kilograms, so this will be your mass, that have package have the seats on the shelf, that is, the height is 2.2 meters. Obviously you know G, so your potential energy is equal to mgh, which is equal to 2.5 the kilograms times 9.8 meters per second squared times 2.2 meters, and your answer is 2.5 times 9.8, 2 times 2, so this is 53.9 joules. What work was given, what work was done to give this potential energy? Well, if it's starting to the floor, potential energy initial is going to be 0. Potential energy final is 53.9 joules. So the work necessary to go from 0 to this number is 53.9 joules. Then for this one, number 4, you have a 500 kilograms pig standing on top of a muddy hill on a rainy day. The hill is 100 meters long with a vertical drop of, so this is the height, this is long, but this is the drop, 30.0 meters. The pig slips and begins to slide down the hill. What is the pig's speed on the bottom of the hill? Again, it's starting with a potential energy initial, which is mgh, which is 500 times 9.8 times 30, and has initially a kinetic energy of 0, right? So your mechanical energy, which is the sum of those two, because it says use conservation of energy, so mechanical energy is equal to 500 times 9.8 times 30, so this is 147,000 joules. plus 0 mechanical energy is this. Okay, so if this is the mechanical energy, it's always conserved. So this means this is mechanical energy at the beginning. So this is initial. Final, obviously the mechanical energy doesn't change, right? So it's still this number, which is equal to the sum of potential and kinetic, potential final and kinetic final, right? The potential final is 0 because it's a floor, ground level. So this amount of energy is equal to kinetic energy, which is 1/2 mv squared. And at this point I can solve for v, because this is still 500. So now I have a velocity, which is so this is 250, so 147,000 divided by 250 square root. So this is 24.2 meters per second. Frank, a San Francisco hot dog vendor, has fallen asleep on the job. The earthquake strikes and has a mass of 300, right? 3 times 10 to the second, 300 kilograms, rolls down and reaches the point A with a speed of, so this is the mass, the speed is 8 meters per second. So how fast is the cart at this point B? So also at the beginning, right, you have kinetic energy and you also have potential energy. So initially, right, mechanical energy is kinetic energy and potential energy. Now kinetic energy is, this is the velocity, so you have 1/2 times the 300 times 8 squared. And you have potential energy also, because you have, the cart is at the height of, so the mass is 300 times 9.8 times the height, which is 50 meters, right? So this total amount is equal to times 64 plus 300 times 9.8 times 50. So the total thing is 156,600. So those are the joules. Now final MA is still the same amount, right? The sum of those two, so it's still 156,600 joules, which is equal to, again, potential and kinetic. So kinetic is equal to 1/2 mv squared, which is what they wanted to know, plus mgh. So this is equal to 1/2, the mass is still 300 v squared plus 300 times 9.8 times the height, which is 30 now. So this is equal to this number here. So which means that we have 156,600 minus this whole number, 300 times 9.8 times 30. So this number here is 88,200. This is equal to 1/2 of this is 150 v squared. So when I do this subtraction and then I divide by 150 and I take the square root of this, I have a velocity of 21.4 meters per second. Then, while on the moon, the Apollo astronaut enjoyed the effect of a small gravity. If Neil Armstrong jumped up on the moon with an initial speed of, so you have a 1/2 mv squared to a height of, so he's starting with this and he's ending, okay, and at the beginning he has 0 potential energy, right? Because it's starting from the ground. This jumps up to a potential energy final, and because it's on top of the jump, the kinetic energy is 0. This is 0. So the potential energy is mgh. Okay, but this is the new g, right? Because it's the new, okay, the new gravitational experience. So let's call this one a, because it's a new acceleration. Okay, so at this point a is equal to 1/2 mv squared. I don't need to multiply by m. I mean, if you can, if you want to, but this is 1/2 times the velocity is 1.51 squared divided by the height of 0.7, which is so 0.5 times 1.51 squared divided by 0.7. The acceleration is 1.6 meters per second squared, which makes sense because it's 1/6 of the Earth one. And then in a wild shot, Bo flings a pole ball of mass m off the height of the pool table. Now you notice how I canceled those masses. So technically you do not need to have the mass of the ball. Okay, so you have a mass, the height, so you have initial potential energy, which is mg times 0.68, and you have kinetic energy, which is 0, equal to, again, has to be potential final plus kinetic final, right? The potential final, because it's at the floor, is 0. So from here you have kinetic energy is 1/2 mv squared. So basically you have this equal to this, so you have m times 9.8 times 0.68 equal to 1/2 m v squared. You're solving for v squared. M's you can cancel out. So you have a 2 times 9.8 times 0.68 square root of this. So the velocity is equal to 3.65 meters per second. And that's the end of this worksheet.